Hello, in this video we're going to take a look at how to use Minitab to do goodness of fit, contingency tables, and ANOVA. In our first example, we're going to do the goodness of fit test on the example that we did in a lecture video where we did the whole thing filling in that big table. The first thing that you would need to do in that case is enter in the given distribution. So I've entered that in already right here. And then also your observed values, of which I've entered in right here. Now to perform the test, you would go click on Stat, Tables, and then chi-squared goodness of fit test, one variable. Once you do that, you want to enter in where your observed counts are. Our observed counts are in C2. And then you can either choose equal proportions, or you can specify the proportions, and we want specific proportions. So click on that, and then tell it where those specific proportions are. And ours are in column C1. Next, you can just go ahead and click on OK. So as we can see, it gives me a couple of graphs. This first one tells me how much each of these digits contributed to the chi-squared statistic. So we can see that the number 9 contributed the most, 3 contributed the second most, 4, and then on down the line. It gives us this graph, which is showing us the expected compared to the observed. So we can see that the expected was up here, and then the observed for 1 was down here. So this is just a nice visual of what we expected versus what we observed. And then in the output area, it gives you a bunch of information. It gives you the category, it gives you what the observed value was, it gives you this test proportion, it gives you the expected value, and then this would be the last column in that big table that we filled in. So if you add up all these numbers in the last column, it will give you your chi-squared test statistic, which is right here in your output. It also gives us the degrees of freedom and what our value of n was. And then here is our p-value. So because our p-value is big, if we were going to test this on a 0.05 significance level, then we would fail to reject the null hypothesis, which would tell us that the data actually does fit into the distribution given. If you want to do goodness of fit and you have equal proportions, then when you fill in that box, so stat, tables, chi-squared goodness of fit, one variable, then instead of selecting specific proportions, you would just click on equal proportions, and then you only enter in the observed counts, and then you would click OK. Next, we're going to take a look at how to do contingency tables. And so this was also an example that we did in one of our lecture videos. I have the number of successes and the failures, and this was for different treatments of stress fractures. In order to perform the test for this, we would go click on Stat and Tables, and then we want chi-squared test for association. In here, we want to select summarize data in a two-way table, and then enter the columns that contain our summarized data in this box. And so that is C5 and C6. And then just go ahead and click on OK. And so here we have our p-value. It gives you a bunch of other, it gives you the observed and the expected outcome in a table format. But down at the bottom, it gives you the chi-squared statistic, it gives you your degrees of freedom, and then it gives you your p-value along the top here. And you can just ignore this second row of information, the likelihood ratio chi-squared. The next thing that we're going to look at is ANOVA, and in order to do that, we're going to open up the cigarette data. So here I have the cigarette file open, and we're going to compare the nicotine levels. So that's column C2, C5, and C8, we want to know if the mean nicotine level is equal to each other for all three of these types of cigarettes. So that would be a ANOVA test. And we would click on Stat, ANOVA, and One Way. For this first box, responses are in one column for all factors levels. They're not. Responses are in separate columns for each factor level, so that is the option that we would want to select. And then in the responses box, we want to enter the columns where we can find our data. So that's column C2, column C5, and column C8. And then you can just go ahead and click on OK. And we can see that it gives us this plot. This is a 95% confidence interval for the mean. And so for King nicotine cigarettes, this is our confidence interval, and the dot in the middle is the mean. Here you can see the confidence interval if you hold your mouse over it. And same with this. So this is the 95% confidence interval for the menthols, and this is the 95% confidence interval for the 100s. The output that it gives us, so it gives us a whole bunch of output. At the very top, it tells us what the null and alternative hypothesis was, the significance level of the test, and then it tells us our factors, King, menthol, and 100s. And then here we have our test statistic, the F value, and our p-value. So since the p-value is 0, we would reject the null hypothesis that the means are equal to each other and conclude that at least one of the means is different. And you can see that on the graph. Let's see if, so here is our graph. And by looking at our graph, we would conclude that the King has a higher nicotine level than the menthol and the 100. So that's it for this video. Let me know if you have any questions, and I hope you're having a wonderful day.